Welcome to this special edition of Frequency Matters, the Art from Microwave Update series. I'm Pat Hindle. I'm here with my co-host Gary Lerude and special guest Steve Ellis, Senior Product Line Manager for Interconnects at Pasternack. Steve, welcome back to the show.
Well, thank you. Thank you for having me today.
So one question that I've always wanted to ask people is, why are there so many options and companies for interconnect products like cables and connectors?
So that's a good question. As you know, there are many, many applications where RF cable assemblies are used. They're almost endless. And when choosing the proper interface and the cable that goes with that, as you know, frequency matters. So some products will support low frequencies at high power and very low loss, whereas that same product will not support a frequency of 110 gigahertz, let's say. When you go to those higher frequencies, there's a lot more to consider, and the product that's used is very small, very precise, very delicate sometimes. So the choice of the cable and the interface are very important, driven largely by the frequency that is going to be used and transported across those cable assemblies. Also, today's world, there's an ever-expanding number of applications. It could be vehicle radar systems, it could be high-speed data, and all of those applications are now driving new designs and new needs. For instance, one of the things in high-speed data is there's a large density of interconnect on a board, particularly in a test and measurement situation, where you need to break out many lines and be able to test them with your test equipment. So in those conditions, we're seeing a demand for higher density of interconnect. So there's many gang blocked where multiple interconnects will be in one connector head. Another consideration is there's so many different designs, and these designs, although they are developed by a standards industry group, often there are many, many applications, and so the interface may be well designed, but how they attach to the cable, how they attach to a circuit board, or how they're used on, let's say, the input or output of your product, all of those may have custom or specialized needs. Over time, standard configurations do develop, but in the beginning, a lot of those designs are driven by the end user and the applications that they're trying to solve.
So given the large variety, how do you decide what interconnect is best for a design?
One of the things you should do is take into consideration all of the requirements of the product, including the electrical, the mechanical, and environmental conditions that the product will be used in. So many times, the main driver of the connector interface for the coax or the coax itself is the frequency of use, the frequency of the information that is going to be transported over the coax cable. So many connectors and cables are designed to be very robust and mechanically strong, or to have very low loss. And in those conditions, you may have a very large, very heavy, very robust connector that has a threaded interface. Those cables may not be appropriate for high frequency needs, because the higher the frequency, the smaller the cable needs to be able to support that carrier. Also, likewise, mechanically, as I mentioned, you may have a threaded connection, but you may prefer like a snap-on or a bayonet connection like a BNC or a simple push-on connection, because you may want to reduce installation time or many other considerations. And those same products would not be usable in an aircraft, per se, because of the vibration environment. So the mechanical environment is also very important. And then the environmental conditions, it may be very extreme temperatures, there may be water exposure, there's other environmental conditions that you need to consider as well.
So what are some examples of challenging applications that you've met with your designs?
So an example of a harsh environment might be on a ship system where you have a radar or some sort of communication system on a ship that'll be at the ocean. If you have that in situation, you have a very high salt fog condition. And so the materials used have to be able to withstand that without corrosion or degradation. So that's one example. Another example of a harsh environment might be a vacuum, where you have a product or a device under test that needs to be in a vacuum, but your test equipment is outside that vacuum. So you may need some way of getting from the inside to the outside, and you'll have a hermetically sealed adapter that will not allow the vacuum to be destroyed or reduced if you make that attachment. So hermetically sealed products are very important in different conditions. A lot of space applications and aircraft applications also have hermetic requirements.
So it seems like connectors tend to be an afterthought in many cases. So if I'm a designer that I've been assigned to work on a new system, what guidance can you provide about selecting and specifying the interconnect product up front?
So I would definitely identify the parameters and the conditions first, as we've already said. So take into consideration the size of the interface, the density, how much access you have. So you have many times multiple choices to support the frequency, but your mechanical environment may limit your choices. So once you've decided how the product's going to be used and the environmental conditions it needs to meet, now you can select an interface and a cable that will support those, but also support the frequency of use. So one of the things that I like to do is to, for instance, if you had a link budget analysis, you're a system designer, now you're choosing the cable. Well, somebody may spend a lot of time on choosing the right antenna. They may spend a lot of time on choosing the correct radio, the sensitivity of the radio, and so forth. But they will forget about the fact that there's a cable that goes between the antenna and the radio. If you were to go play with a link budget calculator and you were to put the loss and the length of that cable into the link budget calculator, you can easily see the effects of that cable on your system performance, your signal to noise ratio, your range, your bit error rate. All of those things can be analyzed by putting together your system in a link budget calculator before you make that final choice on the cable that you're going to use.
Good point, particularly if you're talking, as you cited, an antenna going into a low noise amplifier or coming out of the power amplifier, a key consideration. Well, Steve, thank you for your time talking about one of the most important and I think often overlooked components in the system.
Well, thank you. I think as a final note, that's a very important point. It is an RF component. And one of my sayings that I like to tell everybody who works for me is this cable is just as important as any other component in your system. It can be the weakest link if it is not properly spec'd and is not properly planned for in the system. So it's very important that you consider it an RF component.